Now look at this proof. Prove that HNX Hermite's polynomial is equal to 2 raised to power n exponential minus 1 by 4 d square upon dx square into x raised to power n. We have to prove that HNX can be written like this. So for proving this, first of all we have to know what is exponent. Exponent means e raised to power x. Exponent x means e raised to power x, and its expansion is x raised to power n upon n factorial, where n varies from 0 to infinity. If we have exponent of this, means this whole raised to power n upon n factorial and the summation. So just changing x to this thing, we will get the exponent, this value. So now this exponent can be written in further minus 1 raised to power n. Then 1 by 2 can be 1 by 4 can be written as 1 by 2 square, and square is also there. So it will be 1 by 2 d upon dx whole square into power n. So it will be whole power 2n. Now in the next, we can take 2 raised to power 2n common. Again you will left with d upon dx raised to power 2n. Right? Now we have find the value of this expression. Now we multiply it with 2 tx, e raised to power 2 tx. So if we multiply these two, what we will get? This we have already obtained. E raised to power 2 tx we have written extra. Now what we will do, that this e raised to power 2 tx, if we differentiate this 2n times, so e raised to power like e raised to power 2 tx, if we differentiate it once, let it be y, one time differentiation will give us 2tx into 2t. Again you differentiate, it will be e raised to power 2tx, again 2t square. So how many times you differentiate, that power will be of 2t. So similarly here we differentiate 2n times, therefore the derivative of this whole term will be 2t raised to power 2n into e raised to power 2tx. Now 2 raised to power 2n, here also 2 raised to power 2n, that will cancel. So we are left with minus 1 raised to power n factorial, t raised to power 2n, e raised to power 2tx. So this is all we left. Now e raised to power 2tx is independent of the summation, because in summation we have only n varies, so term containing n are in the summation, and e raised to power 2tx out of the summation. Now this term minus t square, we can write this t raised to power 2n can be written as t raised to power 2n can be written as t square raised to power n. Now t square also raised to power n and minus 1 raised to power n, combining both the powers, we have minus t square raised to power n. So if we compare this with the summation formula, that e raised to power x is this, so here the x can be changed to minus t square. So this become the summation is e raised to power minus t square, and e raised to power 2tx was already there. So combining these two, we'll get e raised to power 2tx minus t square. And remember, what is this? This is the generating formula for HNX. So this is nothing but the generating formula, which can be written as summation HNX t raised to power n upon n factorial, using the generating formula for HNX. Now you can compare these two things. This thing can be written like this, because this is exponent that was given in the question. Now e raised to power 2tx again can be written in form of a summation. This is the summation. E raised to power 2tx is this. So you have to raise power n, 2tx raised to power n upon n factorial, writing the exponent in terms of exponential function in terms of summation. Now on the other side we have written the same thing. Now opening this bracket, and you cancel out the term like n factorial cancel with n factorial, t raised to power n cancel with t raised to power n, and comparing this we'll get HNX upon n factorial will cancel, but the terms will be left exponent minus 1 by 4 d square x upon dx square, t is raised to power n. If we separate this, it will be 2 raised to power n into x raised to power n. On the other side we have h n upon n factorial. It is, you can call it is the coefficient of t raised to power n on both sides. So by comparing, we get this n factorial cancel with n factorial, and h and x is given by this formula, which is what we have to prove. Now look at this question. This is 2 marker question. You have to prove here h2n 0 and h2n plus 1 0. What are these? h2n plus 1 is 0, whereas h2n is minus 1 raised to power n into 2n factorial upon n factorial. To prove this, we are going to use here the generating formula. So the generating formula is e raised to power 2tx minus t square is equal to summation hnx into t raised to power n upon n factorial and vary from 0 to infinity. Right, now put x is equal to 0. Why we are going to put x is equal to 0? Because in the question we are given x 0. So x is equal to 0 we put. What we get here? E raised to power minus t square on the other side and vary from 0 to infinity hn 0 t raised to power n upon n factorial by putting x is equal to 0. Now this can also be again written as summation. So it is minus t square raised to power n upon n factorial, where n vary from 0 to infinity. This is again n vary from 0 to infinity hn 0 upon n factorial t raised to power n. Right? So this can be written in the next step as minus 1 raised to power n t raised to power 2n upon n factorial, and here summation hn 0 t raised to power n upon n factorial. Now you can see in this summation all the terms will have even power because it is t raised to power 2n. If you put n is equal to 0, it will be t raised to power 0. N is equal to 1 means t square. N is equal to 2 means t raised to power 4. So all the terms will be even here. So the coefficient of t raised to power 2n, here the coefficient will be minus 1 raised to power n upon n factorial, and on the other hand it is the coefficient of t raised to power n. When it is 2n here, then denominator will also be 2n. So it will be 2n 0 upon 2n factorial. Right? The coefficient of t raised to power 2n. Here it is already 2n, so this is the coefficient. But here it is not 2n, so if n is replaced by 2n, so here also n should be replaced by 2n. So we'll get this thing, which will give us the value of h2n 0. Changing this side, it will be 2n factorial upon n factorial into this minus 1 raised to power n also. Here it is. So this will be the answer to one of the question. And if the odd term is compared, now the coefficient of t raised to power 2n plus 1, is there any term which will be of power 2n plus 1? Because all the terms are of even power. You can also write here that every or all terms on left hand side are of even power. So therefore the coefficient here will be 0. On the other side if we write the coefficient t raised to power 2n plus 1, so if we replace n to 2n plus 1, so it will be h 2n plus 1 0 upon 2n plus 1 factorial. So what will be the value of h 2n plus 1 0? Because the other side is 0, so it will be 0. So for odd terms, Hermite's polynomial at 0 is 0, but for even it is 2n factorial upon n factorial into minus 1 raised to power n.